Let's now look at the mean value theorem. It reads, let f be continuous on a closed interval AB and differentiable on the open interval AB. Then there's at least one point C in AB such that f prime of C is equal to f of B minus f of A over B minus A. What are they saying? Here's basically what they're saying, okay? Let's suppose I have some kind of function here, f, okay? Y is equal to f of x. All right, and let's say that we have A right here, and maybe we have, like, say, I don't know, B right here, okay? So here is f of A up here, here is f of B right there, okay? And they're talking about, we're looking on this closed interval right here from A to B. Then what are they talking about right here? F prime of C is equal to this stuff. Well, what is this stuff? Recall from the very beginning of the semester, this looks a lot like the slope of the secant line connecting points A and B. In fact, that's what it actually is. It's the slope of the secant line that connects these points here. In fact, I could say that this is the slope of this anyway. Let me call that secant line. Secant line. All right, then what does this mean? Okay, this means the slope of the secant line, but what does this mean right here? That means there's at least one point C in this interval right here to where the slope of the tangent line at that point C is equal to the slope of the secant line. What? Well, here's what they're saying. They're saying you have some point C in here to where whenever you take the slope of the tangent line, it's going to be the same as the slope of this secant line. Let me see, where do I have a slope of my tangent line the same? Somewhere about right there, right? So maybe about that point right there. So here maybe is where I have a slope of the tangent line, and I'm drawing that poorly, where I have slope of the tangent line being the same exact pitch as the slope of this secant line. And where does that happen? That happens at some point C right there. So what we're going to be doing for these problems is we're going to be finding that point C to where the slope of my tangent line is the same as the slope of the secant line that connects these endpoints. All right, so let's do our example here now that we understand what's going on. All right, let's see. We have, on our example, find all values of C in the interval that satisfy the conclusion of the mean value theorem. All right, so we have f of x is equal to x squared minus x, and they tell me from -1 to 3, the closed interval, okay? Now, first of all, is this function continuous on this interval? Yeah, in fact, that's a polynomial. It's continuous at all real numbers, right? Is it differentiable on this interval? Yeah, again, it's a polynomial. It's differentiable on all real numbers. All right, so then it meets that criteria, okay? Then they want us to find a value of C where the slope of the tangent line is equal to the slope of the secant line connecting those endpoints. So let's find M secant, okay? M secant, what did it say? That is what? F of B minus F of A over B minus A. So what does that mean? Well, A is -1, B is 3. So I have A and I have B. So at the bottom here, B minus A, I'll have what? 3 minus -1. At the top, let me evaluate F at B. So F evaluated at 3. So I have 3 squared minus 3 minus F evaluated at A. Let's take -1 squared minus -1. And do this calculation. That gives you the slope of your secant line that connects those 2 points. All right, so that's 9. Minus 3 is what? 6. Minus, that's what? 1. plus 1 is 2 over 3 plus 1 is 4, right? So what is that, 4 over 4 or 1? So I have m secant. I just calculated it, right? I need to find where do I have a slope of my tangent line that's equal to this. Where do I have a slope of my tangent line? What's basically the slope of the tangent line? The derivative, right? So let's take the derivative of this function. 2x minus 1. Now they say find f prime of c. So I'm going to replace x with c here. Now what do I want to find? F prime of c, where it's equal to that slope of my secant line. So where 2c minus 1 is equal to this 1. So that's 2c is equal to 2, or c is equal to 1. Now double check that this number is in your interval. Is 1 in between -1 and 3? Yes. So there's my answer. That's all there really is that we're going to cover in this section.